Hello everybody. Now let's see the various list of tools. Let's see the list of tools that are used in model based development. I'll just go through the list because explaining each and every tool is well beyond the scope of this particular training session, because each and every tool is a huge ocean in itself and explaining it is not possible within this particular training session. Okay, separate training sessions are available for MATLAB, for Simulink, for Stateflow. I recommend all of you to go through those training sessions in case you are interested. All right, for model based development, I strongly recommend MATLAB and Simulink because these two are the tools which are maximum used by various OEMs for the model based development. Okay, so the model based development tools are MathWorks, MATLAB, Simulink, Stateflow, and Automotive Toolbox. All right, and by DSpace, System Desk, Target Link, and Target Link, by ETA's Asset, by Vector, Prevision, and Dyna4. Now a special mention about Prevision. Prevision is exclusively used for the development of architecture, whether it is zonal architecture or central architecture or domain based architecture. It is exclusively used for the domain architecture, the wiring harness, the various positioning of the various ECUs, the various communication protocols. All these things are thoroughly displayed by Prevision. Next is code development tools. In the code development tools, the major compilers used are Greenhills, Tasking, and Hitech. And for static analysis, Polyspace, Coverity, and Clockwork. And for debugging, Lauterbach Trace32. Now this is a very commonly used debugging tool, Lauterbach Trace32, and PLS UDE, which is entering into the market nowadays. Now what are the various standards that need to be considered for developing a software? ISO 26262, functional safety, AUTOSAR for the software architecture, MISRA for coding guidelines, and SORTIF, the safety of intended functionality. Now what are the various steps or various steps in this verification and validation? Unit testing, integration testing, system testing, vehicle testing, and formal methods. Now all these things are clearly explained in the session about in-loop testing. All right, you will find clear elaborate explanation about all these above mentioned testing methods in the in-loop testing session. And what are the various future trends? In the future, more and more AI is being used, and next is digital twins. Now digital twins is becoming more and more popular nowadays. I strongly recommend all of you to go to internet and search what is meant by digital twin, especially in the ADAS scenario. Continuous integration of various ADAS development pipelines, cloud based development. What is meant by cloud based development? This is actually very much used in machine learning, so that a machine or a ECU can learn automatically what is happening on the various vehicles. The learnings of the various vehicles are accumulated or accrued in a cloud, and that knowledge is used to intelligently take a decision in a given vehicle. That is called cloud based development and standardized interfaces for model and code component interoperability. Okay. Now what is meant by requirement tagging and traceability? Now this is extremely important topic when it comes to model based development. Okay, now everybody, I already explained you what is meant by model based development, so let's touch upon what is meant by requirement tagging and traceability. In short, in a very simple language, requirement tagging and traceability ensures that all the requirements mentioned by the OEM to the tier 1 are captured for further development. Understand the sentence very carefully. To ensure all the requirements mentioned by the OEM to the tier 1 are captured in the further development, which includes the compliance with standards, which includes the changes in the requirements, and which includes the proper requirement implementation. Okay, now let's elaborate on this requirement tagging. Requirement tagging refers to associating unique identifiers with each requirement and linking them to corresponding model blocks. Understand this sentence very carefully. So it is like labeling each and every requirement and tagging every label to a corresponding model. Okay, be very clear about this. Now, why tag requirements? Because this ensures that no requirement is overlooked. We have to make sure, as I said, this ADAS is extremely important and development takes lot of complexity. Because once the software is developed, returning back to the board and then developing software is a very cumbersome process. So while development itself, we have to make sure no requirement is overlooked. And it also helps in automated verification and validation. It facilitates impact analysis when requirements change. Okay, so this facilitating impact analysis is extremely important when requirements change. Now, how does this tagging work? How does this tagging work? Let's further elaborate. Each requirement, for example, a simple requirement, system speed limit is 50 kilometers per hour. That is assigned a unique ID, a requirement 123. Okay, and this ID is linked to the test cases and the model components. Okay, so that's how you ensure none of these requirements are missed. Now let's see a simple example in MATLAB. Requirements are stored in Microsoft Word, Excel, DOORS, dedicated tool like Simulink requirements. Now requirements are majorly used in this, especially DOORS. Tools like DOORS or Polarian are majorly used for storing the requirements. And the requirement link is created between Simulink block and the requirement. Okay, Simulink block or the model block, there is a requirement link. Okay, that's how you ensure none of the requirements are missed. And the tags appear in the model practices for traceability. Now this plays a very important role in traceability also. For example, in the later point of development, if you find out that there is some problem, you can easily trace where exactly the problem is. That is also one of the important reason, or that is also one of the important responsibility and application of tagging. Now let's see what is traceability. Traceability, now this is something which I already touched upon. Traceability ensures that there is a clear bi-direction relationship between high-level requirements, components, generated code and test cases. So whenever there is any issue, these can also always be traced back. That's the reason I am drawing this arrow in the reverse direction. Where exactly is the problem in the model component or the generated code or the requirement, it can be clearly traced back, and that is the purpose of which this traceability. Forward traceability, backward traceability, all these things are extremely important. And also there is something called, these are the types of traceability: forward traceability, backward traceability, horizontal traceability. All these things are very important. Now why is this traceability important? Especially during the change management. Suppose you want to change a small feature, then what is the ripple effect? How does the one small change affect the various things? That is clearly identified. Next is impact analysis. Next is compliance and audits. This is also very important for audit, especially for ASPICE audit, because nowadays many OEMs are asking for ASPICE level 2 when it comes to tier 1. And in ASPICE, traceability is extremely important, which is clearly explained in the session about ASPICE. Next is the impact analysis. Alright, so we clearly understand the impact of the change on the cost, schedule, redesign. Schedule means the development time. All these things are clearly identifiable when traceability is intact. Now what are the various tools that support the traceability? Simulink requirements is there, DOORS is there, Polarian is there. I personally worked on this DOORS and Polarian. These are very beautiful tools. Next is Enterprise Architect, which is used for architecture. And this JAMA Connect and Dassault systems are some of the state-of-art technologies which are making foray into the automotive industry nowadays. Okay, now I request all of you to pause your video here and read these things. This is very easy to understand. That way you will clearly understand what exactly is the requirement ID and how it is getting tagged and also how it is getting traced. You please pause the video and see for yourself, because I am encouraging you to read for yourself so that you will remember for a long time. Please read for yourself and figure it out for yourself. Take it as a challenge. Alright. Now what are the benefits of the requirement tagging and traceability? Reduces errors by ensuring all requirements are implemented. Now this is the most important thing. None of the requirements should be missed. This word all, this is of paramount importance when it comes to requirement tagging and traceability. Speeds up the debugging, quickly locating requirement related issues. Next, it supports the certification, especially this ASPICE certification, ISO 262 also, because functional safety requirements and functional safety traceability also is very important. So that's the reason it supports the certification, and it improves the collaboration between systems, software and test engineers. Okay, right from the system requirement engineer to the software development engineer to the actual verification validation test engineer, there is clear connection, there is a clear bidirectional traceability which ensures a proper collaboration between these three verticals. Okay, now let's conclude this by giving a small summary. First is requirement tagging, assigning IDs and linking them to the model elements. Next is traceability, maintaining bidirectional links. This word bidirectional is extremely important. Anybody who gets into career in system engineering for ADAS or for any vertical for that matter, but because we are discussing ADAS, let's say ADAS for now. Maintaining bidirectional links between requirements, model, codes and tests is of paramount importance. It is of utmost importance. Next, it is critical for safety critical systems to ensure correctness and compliance. Now, I already mentioned upon the various types of models, various types of standards that need to be complied upon so that it meets the compliance requirements. Okay, I hope all of you understood the requirement tagging and traceability. Now, this is a very important question in interview. If anybody asks you how do you ensure all the requirements are implemented, you can just give one single word answer: requirement tagging and traceability. All right, so I just gave you a hint. So with this, I just conclude this session. Thank you.